So we're going to calculate the standard enthalpy of combustion for propane 2-ol. So that means the alcohol group's on the second. So we're going to first write our combustion reaction. So we got C1, 2, 3. We got 1, 2, 3, 4, 5, 6, 7, 8 hydrogens, H8, and 1 oxygen. We're going to react it with O2. We got to balance that out. So we're going to form carbon dioxide and water. We're going to need 3 carbons to balance the carbon. We're going to need 4 waters to balance out the hydrogens. Figure out how many oxygens are on the right. 6 plus 4 is 10. Oopsie. 6 plus 4 is 10. That means that there's a typo. Oh, nope. There's a 9th here. Sorry. So we have 10 on the right. We used 1, so we're going to need 9 more oxygen. So we got 4.5. We are given the information about the enthalpy of combustion for graphite, so we write that. It has a delta H equal to negative 393 kilojoules per mole. I'm going to be quick and leave that out this time like I normally would. H2 is given, and its delta H is negative 286. And then the enthalpy of formation for propanol, propane 2-ol is negative 318 kilojoules per mole. So once again, we're going to modify this so that it ends up the way we want it to. So I don't see any carbon by itself up there. I got O2s in multiple places, so I'm going to worry about this CO2. I need 3, so I'm going to multiply it through by 3, which means I'm going to multiply that by 3. I look at H2Os, 2s, and H2Os. I see a whole bunch of other things up here. I don't see any H's. O2 shows up multiple places, so I might get 4 waters, which means I'm going to have to multiply these all by 4. 1/2 times 4 is 2. The last one, I see this is the important thing, but it's on the wrong side, so I'm going to rewrite it. So that's the reverse reaction. Since I wrote it in the opposite direction, it goes from being an exothermic to an endothermic reaction, so I might put that there. Oh, I forgot to multiply my second equation by 4, I see. So I'm going to put that in as I go through. And now we're going to algebraically check and make sure this works out. So we want to keep these CO2, so hopefully they stay. There's 3 carbons up here, and there's 3 carbons down there, so those cancel out. Let's see. We got 3 O2s on the left side. We're going to need some, so okay. Hopefully we'll have some more. We got 4 H2s over here. We don't want that in our system, so it should go away. Those cancel with the ones in the bottom equation. We have 5 O2s on the left side, but we only need 4.5. Oh, there's a half, so now we got 1.5 there, so that will add up to 4.5, so that's good. And now hopefully everything works out. We got 4 waters. We got our propane 2-ol on the left side. We have 4.5 oxygen molecules on the left side. We have 3 CO2 molecules on the right side, and we have our 4 waters. So we're going to have to multiply that first enthalpy by 3. And add it to the second enthalpy times 4, and then we're going to add 318. We got to change that sign from negative to positive. Add it up, and we get problems. Add up, we get 2005. It's a negative, and the units would be kilojoules per mole. And this is the delta H combustion to propane 2-ol.